Okay, so this is a basic prototype of NavVoice device. Here I have connected the Raspberry Pi 5 with the circuitry of NavVoice device and a Bluetooth speaker. To capture the visual inputs from the surrounding, I have connected my Android device camera with the Raspberry Pi 5 using DroidCam application. Now let's talk about the basic circuitry of NavVoice device. This circuitry consists of 5 buttons which helps the end user to interact with the device. Every button is interlinked with different type of functionality. On pressing the first button, the end user can convert any textual information present in front of him into human speech format. This is done by capturing the input image from the connected camera and processing it internally using GTTS and Tesseract OCR. On pressing the second button, the end user enables a smart face recognition system. This system recognizes people as known or unknown. This system returns the name, gender, age, and expression of the person present in front of the end user using Google's FaceNet engine. On pressing the third button, the image captioning script enable. This captures an input image of the surrounding and returns a human voice output of every minute detail regarding the surrounding. The fourth button is just to trigger the camera to capture the input image or video from the surrounding. The fifth button is to trigger any SOS emergency call. It uses Google's geolocation API to find out the current location of the device and locate nearest medical hospitals and government authorities to alert them if any emergency occurred with the real-time location of the end user wearing the device. Okay, so let's test the device.
Welcome to NavVoice, an artificial intelligence-powered navigation device dedicated to visually challenged people with voice output capabilities. Press the buttons according to your use case. First button is to convert text documents into voice output. Second button is used to detect persons in front of you. Third button is to get overall environment knowledge. Press the fourth button to capture the images, and the last button to make SOS emergency calls.
Okay, so let's press the first button.
Capture the image of the text to generate the voice result.
So as you can see that the input camera is enabled, and this is the text I am going to capture its image through my hardware.
Compare thee to a summer's day, thou art more lovely and more temperate. Rough winds do shake the darling buds of May, and summer's lease hath all too short a date.
Okay, so this was the response of that captured text. Now let's move on to the second script. It will recognize the face of a registered user and identify unknown users.
Exiting text to voice script. Capture the image to identify the persons in front of you.
Okay, so as you can see that my image is visible in that screen, which is captured through my Android device connected to my hardware. So let's press the recognition script.
User Deep 1.
Okay, so I am recognized user and I am related to Deep 1. Okay, now let's move on to image captioning script. This script will capture the image of the environment and generate the voice output.
Exiting the face recognition script. Capture the image of the environment to know about it. View of a street with tables and chairs.
Okay. So this was the complete project, and at the end, if the user face any uncertain experiences or any unexpected experiences, then he can press the SOS emergency button to notify its registered user or his relatives or registered authorities and generate the local alert.
Putting the image captioning script goodbye. Emergency mode activated. Processing emergency response. Emergency alert sent to your registered user, police station, and hospital.
Okay.